Hello, I'm Laura Thomson. This is Rebecca Weiss. We come from Mozilla. We make a little browser named Firefox. And today we've come to talk to you about science. Louder?
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 Am I too loud?
What about now?
I'm fine, right?
Okay.
She's, okay.
Okay.
I'm usually the loud one.
I just talk.
Nothing. There we go. I just talk too fast and have a funny accent, so. Okay, so this talk is about how we reinvented ourselves to become more data literate, experiment driven, and ship faster. But actually, that's a lie. We're still in the process of doing that. We are in the process of reinventing ourselves. So I wanted to be strictly honest with this audience. In the beginning, there was no data, and it was bad. So Mozilla's a pretty old company. I have been there for nearly 10 years, which is like an epoch in the scheme of things. And when I started at Mozilla, there were about 80 people, and now there are about 1,200 people. And we have always stood for the user, right? We're a non-profit. We care about your privacy. And what that meant was that collecting data about our users was very bad, right? We did not do that. You're a bad person for wanting it, right? Not allowed to have data. People who want data are bad. Data is bad. You're a bad person. You make bad systems. You do bad things. But at this stage, we only had 3 pieces of data that we were allowed to have. We knew the number of downloads. We had a little mechanism called block list pings, which was basically once a day, Firefox would phone home and say, is the current version of Flash vulnerable? And if so, we would say, yes, please switch it off. And we would count those, and that would give us a proxy for the number of users. And the third thing was that we would collect crash data, and we still do. This is when your browser crashes, you send us like a subset of the contents of memory, which is incredibly toxic data, right? It has like the URL of the bad thing you were looking at, and like your IP and your email address, and the credit card number and SSN that you typed into a form, and like really bad stuff. So we hated collecting data, but we had this really toxic data. So we were forced to keep it in a monastery and have it guarded by ninjas, and I know this because I was one of those ninjas. So overall, this was a very bad situation. Oh, this is actually like a simulation of what's happening in downtown right now also. Okay. So we were sort of in this world where we were making decisions without evidence, right? We were shipping code, we were beta testing it on hundreds of millions of users with no information. And we were making product decisions based on what engineers thought were a good idea. Also, I need to point out that sort of going back 10 years, we didn't have product managers because we didn't really know what that was. So we found ourselves facing questions like, I shipped this new feature. Did it affect retention? Did in fact it make people want to use Firefox more? Did we regress performance? We had test infrastructure, right? So we knew if Firefox got slower on our test harnesses, but it turns out users have all kinds of crazy graphics cards and very old operating systems and all those kinds of things. So, how often do users experience jank? Jank being that thing where you try to scroll and it kind of doesn't, and it's really ugly, and we didn't know. And how many users do we have anyway, right? We had this block list ping, but it wasn't very informational. So, real questions, ones that we could not in fact answer. It turns out that making a browser is kind of hard. It's not like making other software in many ways. I came from a background as sort of web dev, DevOps sort of person. And client software is hard, right? So here's basically what we do in a nutshell. We take a piece of compiled software and we install it on hundreds of millions of machines on every combination of hardware and every operating system in 200 different languages in 200 different countries, and we let the end user download arbitrary code from the internet and run it on our client. It's a little bit kind of challenging. So it's kind of like an app, except it's sort of not. It's also kind of like a service, except it's sort of not really one of those either. It has some service-like attributes, right? We have embedded services, we have Firefox accounts, we have location services, now we have telemetry. But there's some slightly different characteristics about writing this kind of software, and that makes it hard. But the way we like to think about this is not to say that Firefox is a special snowflake, but that in fact Firefox is a beautiful, mystical whimsicorn, gambling through the clouds. But yeah, so we have measurement problems. Browser usage is very seasonal. It turns out when the weather is nice, people do not use their browsers as much. And also college students are out doing things other than sitting at a computer. It's very complicated. We have the web changes every day. People ship new websites every day, and they ship a new website with new JavaScript that breaks everything. And people use the internet in ways that we don't expect. And we have to work all of the time despite all of these things. Because the first time you load a website in a browser and it doesn't work, that's when you switch browsers, and there is zero switching cost. Okay, so we decided we would start building some measurement systems, and this is how we went about it. We have a question. We will build a specialized, precise system to answer this question, and we will answer it. Yay! Then we will ask another question of the same system, and because we built this specialist system and deliberately constrained it so we wouldn't collect any more data than we had to, we would fail. So then we would go forth and build yet another measurement system. There's nothing wrong with this approach whatsoever, especially if you are somewhat, don't have an infinite budget and are somewhat constrained in what you can collect. And we ended up with kind of 4 main systems. I talked a little bit about the blocklist ping originally. That one is default on. You can turn it off if you want to, but it's on. So we have a reasonably good idea of the number of people using Firefox every day. We then built this system called telemetry, which is what it sounds like. It's a telemetry system. And it measured performance. It was very engineering-y things. We had histograms from the very beginning, which is nice to know. But they would tell you really useful things like, this is the number of milliseconds to first paint, and here's a histogram with buckets of how many bookmarks users have on average, and those buckets are like 0 to 100 and 100 or more. We later then built a thing called Firefox Health Report, which was the very first opt-out telemetry we had built, and this was incredibly controversial. You can look back at the bugs, and there's people saying, you will never be able to ship this in Europe. Google won't be able to ship it in Europe either. You cannot have any kind of client ID. Every measurement has to be independent, and no longitudinal measurements are allowed, and no client IDs. It's very challenging. Other than that, we also obviously continue to run our crash reporting system. So, if you want to know how we deal with privacy, by the way, our privacy policy is on our website. And if you don't trust us, you can go and look at the open source code to make sure that we're telling you the truth about what we do with it. And if you are more paranoid than that, and I do work with some people who have very shiny tinfoil berets. We're working on binary transparency, so you can in fact verify that the code that you see in the repo is the same code that's running on your computer. So we bend over backwards to make this work. If you would like to adjust how much data you send us, this is in your preferences under advanced data choices. It tells you exactly what you send us, right? Which is really nice. We're very transparent. Okay, and now I will let Rebecca tell you about where we have come to after all of that mess.
Yes, because I'm on the data science team, and what ends up happening is all of these different collection systems, they're all really just sampling methodologies that are sampling at different levels of observation. And so from a perspective of a data scientist, this means that there's these interesting statistical properties to every single one of them, which means that every single time someone would ask us a question, even a simple one, we'd have to go through this list of caveats about what you could and couldn't conclude from a particular way of measuring a thing, because that's just the way that the math works. And no one wants to hear that, because it's a lot of caveating right up before you could even get to answering the question. So what that meant is that an engineer would be like, I don't want to deal with that, I don't want to deal with that, I'm just going to build my own thing because I know what I want to get answered and I understand this policy and I'm just going to make it work. So we think there are like 4, there's probably a lot more, but these are the 4 that we end up doing a lot. The other thing is yes, privacy still is a thing that we have to worry about, and we didn't really have a clear policy, and we still are kind of developing our policy around how we think about it. We don't really have a lot of guardrails in this case, because to the user, your privacy is protected until it's not. And then it's a violation of privacy, and that's a reality that we have to live with. So we kind of just had this world where we were only thinking like privacy and collecting more data, they're zero sum, we either protect privacy or we don't, and that meant that we had no flexibility with the way that we approached the problem. Next slide. You guys are seeing all of our notes. I'm cheating. Next slide. Can you press play, please? No one likes to look at red for this long. Yes. So, what this meant is that we were in this world where we were our own worst enemies. And if you look at any of these bug threads that are related to any of these measurement systems, you can see how much we fought about this. And it's this horrible position to be in, because you want to make a better browser, you want to make a better product, you want people to enjoy the web the way that we think that they should be enjoying it. But you can't do that when we don't know what's going on, because we don't actually have any measurements to help answer these questions about what's driving users away, what do they not like about this. So we were our own adversary. We were beating each other up. Next slide. And meanwhile, we're not unaware of the reality of the world. Next slide. Maybe I should just take this thing. Yes, I can do this. Yes, we are aware that our market share is going down. So this is the global desktop market share as reported by StatCounter. And the way to look at this graph, it's not so much this is the number of users that we're losing, or this is the number of dollars that we're not making, because again, we're a nonprofit. This isn't the way that we think. The way that we think about this is that this is our mind share. This is the vision of the web as according to these companies that make these browsers, and our vision isn't winning. And that's a real problem for us. And it's a real problem for you.
So we decided that we need to move on. And really, we have been talking about this as if it was a data problem. And what it really is a culture problem. Surprise, surprise, they often are. So it turns out this is hard, and we needed to get better at it, get more transparent about it. Skipped ahead. And we needed to figure out that we needed to change the way that we measure, have better measurement systems, and find ways to be more experimental. And all of that means culture change. So we decided we would build a data culture based on scientific principles, which sounds much more scientific than it is, to be honest. But there are 3 basic pieces to this, and I'll talk about each of them in more detail. The first one was that we decided that we needed to focus on consistency and reliability over trying to build very precise, specialized systems. That's one. The second thing was that if you've ever built a system for a small number of users, which probably everybody in this room has since you mostly make tools, you realise that you end up building consultingware. Like you end up building features for the people that scream the loudest, as opposed to sort of serving a general audience. So we wanted to try and prioritise a situation where people could serve their own needs pretty easily. And the third thing was that we really wanted to build like a badass experimental platform and do it very quickly, because we had left it kind of late. You saw the graph. Things were bad by this time. Okay, and we also settled on having a single data collection system. Not 4, but 1. We're not there yet, but we're getting there. It would be the one true ring of data collection systems, my precious. And we focused on this. There are many, many different kinds of things that we need to measure, right? From performance measurements to user interactions with the browser. You know, we had no event measurement on, you know, we don't even know if anybody uses a particular feature, right? Think about that, it's kind of blinding. We wanted to have one good system instead of many, many half-baked systems, and a single mental model for what a ping looked like, right? What was the structure of a piece of data collection? We settled on kind of like a rich structure, which I'm really happy with. But it also means we have one set of quirks. You're not trying to deal with the combinatorial quirks of many different systems, and one set of errors. So it's just much more easy to reason about something like that. So in terms of this, we're trading off for sort of precision on specialised measurements, but that is a thing that we can deal with later. It is hard to be precise if your systems are not up. So, okay, so choose ops, choose self-service services. Most of you have probably seen this cartoon. If you have not, I will read it to you if you're in the back row. How do I query the database? It's not a database, it's a key value store. Okay, it's not a database, how do I query it? You write a distributed MapReduce function in Erlang. Did you just tell me to go fuck myself? I believe I did, Bob. Now, the really sad thing about this cartoon, and I've had it pinned up on my wall for several years, which is when we started with telemetry, this was true with one exception, except that it was Lua instead of Erlang, right? But this represented reality accurately. And it's kind of fine if you're an engineer, but when a product manager comes to you and says, I really want to know if users like this feature, and you say, you can just write a distributed MapReduce function in Lua, Bob. And then they punch you in the face. So self-service is important. Okay, so we have built what we have on a series of open source tools. And some of these are going to be familiar to you as a group, and some of them are not. The first one in particular, put up your hand if you've heard of Redash. Not very many people. Redash is awesome. I want you to go forth and embrace Redash. So it's a Django-based web app. It talks to just about any tabular data store. So we have it talking to like Presto and Parquet, but it also talks to like Postgres, MySQL, whatever it is. And it lets you easily build dashboards for relatively simple queries. The thing that is really nice about it is that it is social. I can look at the dashboard that you made, and then I can view source for the code. It's like the web. And then I can fork your dashboard like it was on GitHub and tweak it a little bit and make my own dashboard. And this is awesome, and encourages a lot of people who are like, well, I kind of know, did a little SQL in college, but I haven't done any since. Or even if they haven't done anything, it's like the web, they can teach themselves. and has been incredibly, incredibly successful. So we like this so much, we gave them an open source grant to make it even better, and I encourage you to go forth and use it. Other things on this slide, Airflow, which is Apache project, monitoring and job scheduling for dataset creation. We use pretty standard tools, Apache Spark, Parquet, Presto, and many, many more that I'm sure I am not listing out. And Rebecca's going to talk about the workflow for data science.
Yeah, because you might have noticed that the thing that's common about all of these tools is that they encourage a lot of this visibility between the stages. So the way to think about this is that in science, you have this idea of like knowledge has to be reproducible. You have to be able to identify that a thing was observed and that a thing was true at a time, and what were the steps that were taken in order for that thing to be verified as actually still true. We still see this all the time because the truth is when you work at a place with a lot of opinionated skeptics, you need to bring a lot of evidence to the table. So every single step of the number that we get in a slide, we wanted to be able to audit it all the way down. So yes, so this idea of like enforcing a citation needed culture, it might seem a little bit like aggressive, but the truth is, again, like you want to have evidence to back up your decision making, especially if you're the kind of person that has to make a judgment about some kind of really challenging thing. You want to be able to feel like you've made the most informed decision as possible, and so that means you need to trust the data that you're getting. And this is a problem that we were running into, that when people couldn't touch the data, or if they couldn't see how it was created, they didn't trust it. And it was super, super easy for you to say, well, but what about this, and us not having an answer for that. So now we can say, well, this is the number in the slide, and if you click on this number, here's the redash chart that it comes from. And if you want to know how that data set was created, here's the Airflow job that created it. And if you want to know the fundamental theory about why we even started looking at the data in this way, here's the notebook or the R markdown script or whatever it is that we're supporting at that level that allows you to say, like, from the pings themselves that came from the client that was measured with this code, because our code is open source, this is exactly where it all comes from. And we can audit that number all the way down. And that is something that we it's just been sort of like a really monumental change for the way that we think about knowledge.
Yeah, and actually, I want to tell a story about why we make this citation needed joke. I think this is an anecdote that kind of illustrates how much trouble we were in. We had a slide that had been presented to the board, and we needed to update that slide. And it doesn't really matter what the data was that was on it. But the person that had drawn the graph on the slide had left the company. So we set out to draw the 3 months later version of the graph. And we had 2 different data sets measuring that thing, and neither of them could be used to make the graph on the slide. So we drew some different graphs, and then you'd have to have that great conversation with your board about we don't know what we're doing. But here's the new data, and now we know what we're doing, and next time it's reproducible, and now it has a URL, and you can go and check it for yourself every single day if you want. So we learned that one an exceptionally hard way, and I would not wish that on anyone. Okay, so we're making progress, and this is kind of what success smells like. This is a graph of the number of active users on Redash. So we have 623 accounts on there now. If you know that there are about 600 people that work on Firefox directly, it's a pretty good number. We have about 150 active weekly users. That is people who are actively coming and digging into our data every week. That's awesome. I'm really excited about that. Okay, and some of the data, we're trying to publish more and more of it because it's not all public because of this sort of conflict between Mozilla desperately trying to be open about everything and also being really conscious about preserving user privacy, right? So we are trying to publish as many of our data sets as possible while doing that. One that's relatively new is the Firefox hardware report. If there are any devs in the room, probably interesting to you, there's a URL where you can visit this. And it tells you things like what graphics cards are people running and what processors do they have and what do we see as like the spread across the market. And this is really interesting data, right? Because there's a really large number of users involved in this. Okay, the other thing, the third dot point in the platform was to build a badass experimental platform. So now I'm going to talk about our experimental approach. We don't really like to say that we're data-driven because that sounds like you have no volition, but we're data-informed and maybe a little experimentally driven. So, okay. Now, one thing I need you to know is, I know there's at least one person in the room that used to be a Firefox release engineer. The way we build Firefox is complicated. It's very old. We have one of the earliest continuous integration systems, I think, that was sort of like publicly documented or shared. We still have extensive use of BuildBot. It's kind of disturbing. And so working into any kind of like experimental thing where we had like pref flipping, feature flipping, A/B testing, very, very challenging. So I left out the slide with the horrifically complex release infra diagram because the world needs you all in this room. We need you to be sane. Right? If you look upon this diagram, it's like looking into the abyss. The diagram will look back at you, and it knows where you live. Oh my God, I forgot to take it out. Don't look at that. Don't look at that. Cover your eyes. Okay, so moving on. In the bad old days, we still managed to find ways on top of this horribly complex infrastructure to ship experiments. And we had three kind of initial ways. The first thing was an idea of a thing called a funnel cake. I do not know where the name came from, but we talked about donuts for half an hour, and now we're talking about funnel cakes. You're all really hungry, right? A funnel cake was a special build. So with different code, we built it from scratch. It still took more than 12 hours to build it. And then we ended up like A/B shipping it through like an Apache rule with some kind of random dice roll. Do not ask me how crufty this was. It's exceptionally crufty. So yeah, pretty crufty. Second thing was what's called a telemetry experiment. That was where you made an add-on and you shipped it, but there was a lot of paperwork you had to do first, and you had to talk to lawyers because we were so worried about like infringing on our users' rights by shipping them untested code. So that kind of sucked. And the third thing was this really good idea called Test Pilot Mark 1, or somebody was calling it Test Pilot Classic, but we all know Classic is the good one and new sucks, so I'm not going to call it that, which was the idea that users could opt into trying a new feature and tell us if they liked it. Okay, and the problem with these was that they weren't really open science, right? They kind of sucked. The barriers to entry are really high. You had to be able to make a special build of Firefox. You had to do so much paperwork and so much approval, and every piece of data you wanted to collect, you had to be able to prove there was a direct user benefit to that specific piece of data, or you would not be allowed to collect it. And it just wasn't very production-y, right? Like, it didn't scale. If you wanted to do one of these, it was going to take you like a month, 2 months to get it out the door, and that's really not like a velocity that you can sustain for, making a living. So we invented this program called Go Faster. Yes, I named that. Engineers should not be allowed to name things. And as one of the people I work with, Dave Camp, pointed out, you shouldn't call it Go Faster, you should call it lower latency. I'm like, that's even worse, Dave. Let's not call it that. But there are several parts to this program, and one of them is a thing called system add-ons. And these are actually not, so to speak, an experiment, but they sort of form the basis for some of the other work. A system add-on is a part of core Firefox that we ship as an extension to Firefox. So if you go and you install uBlock or Ghostery or NoScript or whatever it is, it works the same way as one of those, except that it's privileged. Like we know that it's made by Mozilla and it's signed with Mozilla's signing keys. The nice thing about those is they're web stuff, right? They're written in JavaScript, and you don't need to build Firefox to ship one, and you can ship one every day, or more often if you want to. You ship it like it's a web app. It's really nice. So they're not really an experimental mechanism, but they have enabled us to be more experimental. It took us a really long time to ship electrolysis. If you hang out in Hacker News, you may have followed some of that. That's like our multi-process architecture. And using system add-ons, we could ship those because we put a whole bunch of intelligence into the client that decided whether your client was ready to turn this on or not, basically. So it was good. Second thing we did is Test Pilot Mark 2. I encourage you to look at it, testpilot.firefox.com. And this is a place that's very producty. Like, this is where we actually try new features on you and see if you like them. They're very early new features. A lot of it is just do you think this is a good idea? Is this something you would use? Some of them are further along. And the nice thing about these is successful ones can actually graduate into Firefox. We're doing our first one of those right now. I think it's going to be in Firefox 55, but don't quote me. And that's Firefox screenshots. Try it out. It's actually really cool. So that's program 2. And the third thing, which is kind of the really shiny thing, if you ask me, is Shield. So Shield is a program that lets us do a bunch of things, but Shield studies use actual statistically valid sampling to sample our users and offer them the ability to participate in an experiment. And in those experiments, we can do a bunch of things. We can flip preferences, we can install a brand new feature, we can collect extra data, and we can have multiple experiments in flight at once. And this is like the promised land, right? And Rebecca's going to tell you a little bit about this specific graph, which is from a Shield study.
This graph's kind of cool because, again, you have to remember that we don't know a lot about what you're doing with the browser. We just have a lot of assumptions that we think are true, but we don't actually know, and we don't have access to your camera, and we're not looking at you, and we don't have your microphone, so we can't listen to you. All we can do is observe you with some degree of respect. So this was a study that was written that allowed for us to start asking people, like, why do you hit the reload button? Because we had no idea. Like, the reload button could be, the page is broken and I don't like it. Or it could be like, you are a web dev and you just are constantly developing. Or the thing that we were all kind of like, that can't possibly it, but maybe it's some part of it is you want fresh content. And so what this graph does show, which, you know, we're not going to go into all the details of all the sampling and everything, but the gist of it is the gray bit is like, we didn't ask you, because that's, you always have to have a nothing burger in an experiment. The red one is you just, you know, you got the prompt when you hit the reload button and you didn't respond. The blue one is fresh content, and everything else was all the theories that we cared about. So what that revealed to us is that our fundamental understanding of why people use the reload button was wrong, and that we needed to start thinking about this entire way of thinking about user flow differently, and that's what we're actually starting to do now. So the thing to remember is that we are sort of mid-stride at this point. That's kind of actually the theme of this talk, because again, we haven't actually reinvented ourselves, we're kind of in the process of doing so. But the important thing was for us to recognize that we can still be this privacy-protecting company. We can still believe in our principles and the mission that we have, but we can also evolve on the way that we think about data and collection and measurement, because it's just kind of like, again, not to belabor the point, but like we're not doing all that great in terms of mind share, and part of the reason why this is not the KPI you want to measure yourself against, because this is an experiment against driving users away. And that's not a good way to think about building a good product. And this is a very coarse measurement. It doesn't allow for us to actually look at feedback on the way that our browser's working. It's kind of like a lagged indicator, and it's not a one that we should really be trying to practice on. So the gist is that as we get better at thinking about measurement, and as we get better about monitoring and building these tools and infrastructure to actually answer some of these questions about what's making users' experiences not so great, it's going to influence the priorities that we put into what technologies we develop. It's going to change the way that we think about feature development, and it's going to change the way that we think about the browser as a product entirely and the web as a whole. So for all of you people that think about monitoring all the time, there's a real story here for you to help understand and help us understand what the web should become and what it should be, because like it's going to be driven by the data that we collect on this platform. So with that, I would say contact us if you have more questions or if you have some feedback.
Thank you.